this final video, we will explore how generative AI can support us in providing pedagogical assistance to our students. Although this is a simplification, we could say that there are two main types of generative AI models: GPT models, Generative Pre-trained Transformers, and RAG models, Retrieval-Augmented Generation. In the next few slides, we will explore their main features and how they can be used in education. We will start by looking at GPT models, which are the most widely used and well-known. In this slide, we are introducing GPT models, Generative Pre-trained Transformers. These are the most widely used generative AI models in education and many other fields. GPT models generate text independently, based on what they have learned during training. They do not consult external sources at the moment of responding. Their key features are that they are generative, pre-trained on large amounts of text, and based on transformer architecture, which allows them to understand context and generate coherent responses. Examples include popular tools such as ChatGPT, Gemini 2.5, Claude, and others. In the next slide, we will look at what they can do and their limitations. This slide shows 3 practical uses of GPT models for teachers. These are tasks where generative AI can save time and improve quality. First, teaching material generation. GPT tools can help create summaries, glossaries, case studies, or reading guides adapted to different student levels. Second, planning and communication. GPT can support us in organizing timelines and writing more effective messages for students or our academic teams. And third, feedback. This is a critical area where GPT can assist in drafting personalized, informative feedback, helping us respond more quickly and with more detail. This slide presents 3 ways GPT models can support student learning. First, in study assistance, GPT can explain complex topics in a personalized way, using analogies or summaries that match each student's level of understanding. Second, it can assist with academic writing by helping students structure their ideas, revise drafts, and improve the clarity and coherence of their texts. And third, GPT can be used to create self-assessment tools, such as quizzes or flashcards, that help students consolidate knowledge and prepare for exams. These applications can promote autonomy and support self-regulated learning in digital environments. This slide highlights 4 key advantages of GPT models in educational contexts. First, rapidity refers to the model's ability to quickly generate teaching materials, saving educators valuable preparation time. Second, adaptability means GPT outputs can be tailored to suit the learner's level and preferences. This is particularly useful in differentiated instruction. Third, GPT provides accompaniment, a permanent support tool that can assist students and teachers throughout the learning process. Finally, its versatility allows it to be used for a wide range of tasks, from academic content generation to course planning or institutional communication. These advantages make GPT models especially valuable in digital and hybrid education settings. Although GPT models are powerful tools, it is important to understand their limitations. First, they may produce errors or hallucinations. This means they might invent data or cite authors that do not exist. This is a known issue in generative models. Second, GPT responses may lack curricular alignment. While they are coherent, they are not always tailored to specific learning goals or the structure of a given course. Finally, GPT models do not have access to real-time data unless connected to external systems. This means that factual information may be outdated or incomplete. Being aware of these limitations helps us use the tool critically and design safer educational applications. Now we will look at a different type of generative AI model, RAG models, which stands for Retrieval-Augmented Generation. These models are more reliable because they combine a language model with a real-time search system. This means they don't only rely on their training, but can also retrieve external documents or datasets while generating the response. This improves accuracy, helps reduce hallucinations, and allows the model to cite specific sources. In the field of education, this means we can use AI more safely to support tasks like research, grading, or preparing materials based on updated content. Let's now look at how RAG models work in 3 simple steps. First, the user asks a question, for example, requesting a summary of a long document or asking for clarification on a topic. Then, the system searches the external sources it has access to. These may include course materials, scientific articles, or institutional databases. Finally, the model generates an answer by combining what it retrieved with its trained knowledge. This process improves accuracy and transparency, as the answer can be traced to specific sources. From the student's point of view, RAG models offer several practical benefits. First, they help resolve doubts by giving accurate answers that come directly from the course materials chosen by the teacher. They also support study preparation by generating outlines or summaries of key topics. In terms of self-evaluation, students can use RAG tools to generate practice questions or mock exams. Finally, these models can assist with academic assignments by helping students organize their work and search for relevant content. This means students can study more independently, but still based on reliable, teacher-approved sources. From a teacher's perspective, RAG models bring important benefits to online education. First, they allow us to create customized resources. We can prepare materials adapted to the level and context of each group of students. Second, they support the design of formative assessments that are aligned with learning objectives. This makes evaluation more meaningful and targeted. Third, RAG tools are very helpful when explaining complex concepts. They can generate examples, analogies, and explanations using trusted sources, which help students understand the material more easily. All these features make RAG a valuable support tool for designing engaging and inclusive online courses. Pedagogical advantages of the RAG approach. First, it enhances contextualization. Since the responses are based on the specific materials chosen by the teacher, they support coherence and consistency with the course framework. Second, RAG models enable customization. Each student can receive responses tailored to their learning style, background, and progress. Third, they promote autonomous learning. Students can explore content independently, knowing that the information is reliable and aligned with the course. In short, RAG supports both personalization and academic rigor. This slide summarizes the main benefits of RAG models in educational contexts. First, they enable accurate responses because the answers are based on carefully selected materials. Second, they help to contextualize content. This means the responses align with the course syllabus and learning goals. Another strength is that they can easily integrate new sources without the need to retrain the model. This flexibility is important for teachers who update their materials regularly. In addition, they provide traceability so students and teachers can check the sources used. This enhances transparency and academic integrity. Finally, RAG models are ideal tools for both teachers and learners, supporting a more personalized and efficient learning experience. This slide presents a side-by-side comparison between GPT models and RAG models. GPT models rely entirely on their training data. They are flexible and perform well in general tasks, but they can produce hallucinations or unverifiable information. Also, updating them requires retraining the entire model, which is resource-intensive. In contrast, RAG models retrieve information from external sources. This allows greater accuracy, especially when using course-specific materials. Another key advantage of RAG is traceability. Users can see the exact source of the information. And importantly, these models are easily updated by modifying the documents in the retrieval system. No retraining is needed. In short, while GPT models are great for general use, RAG models are better suited for educational contexts where accuracy, relevance, and source transparency are critical. In this final comparison, we focus on how each model can be applied in educational practice. GPT models are highly useful when speed and creativity are key. For example, they can be employed to generate general texts, paraphrase, write summaries, or explore alternative formulations of ideas. Their main advantage is speed and ease of use, since they do not require connection to any source of documents. However, they do not ensure fidelity to curricular content. On the other hand, RAG models are particularly helpful when precision and alignment with course materials are required. Since they retrieve and use specific sources selected by instructors, they are ideal for personalized tutoring, academic search tasks, and content-specific support. The trade-off is that RAG systems require a technical infrastructure to manage and access source documents, and their responses take longer because they involve retrieval and integration. To sum up, GPT models are more flexible and efficient for general tasks, while RAG models are more accurate and pedagogically appropriate when we want to ensure alignment with the learning objectives. During the workshop, we will use a free Google application called NotebookLM. It is based on a RAG model. NotebookLM is a free tool developed by Google. It allows us to create a personalized assistant that only uses the documents we upload. This means it can help students or teachers based on specific content. It works with RAG technology, which makes the answers more accurate and source-based. NotebookLM allows users to upload up to 50 documents in the free version. This is usually enough for educational tasks. In the premium version, the limit increases to 300 sources. It is highly versatile as it works with different formats like PDFs, Google Docs, and even videos, which makes it easier to integrate diverse learning materials. NotebookLM accepts a wide range of source types. We can upload documents from our own computer, connect files from Google Drive, and add website or YouTube links. It also allows us to paste plain text directly. One particularly useful feature is the Discover Sources option, which helps identify additional materials related to our topic of interest. This flexibility makes it easy to tailor the assistant to different teaching and learning needs. NotebookLM offers a range of useful functions. It can generate summaries and study guides directly from your documents, as well as suggest questions for review. One of its strengths is comparative analysis, which helps contrast different sources. Additionally, it can produce concept maps and even generate podcasts in different languages. These tools are especially valuable for supporting personalized and flexible learning. One of the most powerful aspects of NotebookLM is its capacity to interact deeply with your content. Through the interactive chat, you can ask specific questions about your documents. The referral system helps ensure transparency by linking each answer to its source. Additionally, the source guide highlights key information, and the system can even generate draft reports or timelines automatically. These features make it a very effective tool for personalized. This slide shows the user interface of NotebookLM. On the left, we find the Sources panel, where documents can be uploaded and selected. In the center, the chat allows us to ask questions and receive answers based on the selected content. On the right is the Studio, a space where the application generates structured materials like summaries, study guides, or timelines. This layout helps us keep all our resources, interactions, and outputs in one place. How to collaborate using a shared notebook in NotebookLM. To work collaboratively, once a notebook has been created in NotebookLM, editing permissions can be granted to other users. To do this, follow these steps. 1. Click the Share button. 2. In the pop-up window, enter the Google email addresses of the individuals you want to share the notebook with. 3. Select the editor role. 4. Finally, click the Keep button to confirm. 5. When you click Share again, the selected individuals will appear as editors. These are the 4 steps we followed to implement NotebookLM in this training context. First, we created a shared notebook. Second, we upload documents, videos, etc. related to our project. Then, we designed prompts, some in English, others in Vietnamese, to generate context-sensitive outputs. Finally, we used these prompts to produce various materials, from syllabi to case studies and quizzes. Thank you very much for your attention. I hope the video has been of your interest.